All right, 1.3, midpoints and distance. So the midpoint of a segment is the point that divides a segment into two congruent segments. It's the middle, it's the halfway point. So M is the midpoint of segment AB. Therefore, AM and MB are congruent. A segment bisector, similar idea, it just happens to be a point, ray, line, segment, or plane that intersects the segment at the midpoint. So a midpoint or a segment bisector bisect a segment. So just like before, it just happens to be a line here, line DC, instead of just point M, but the line DC is going through M. So therefore, again, AM is congruent to MB. So if point M is the midpoint of VFW, find the length of VM. Well, these marks right here mean they are equal to each other. So I can set them equal to each other and then just solve algebraically. So I'm going to subtract 3x on this side. And that's going to give me x minus 1 equals 3. And I'm going to add 1 to both sides. And that gives me x equals 4. But you have to look. Is it asking you to find x? No, it wants VM. And at this point, you have to pay attention. Is it asking me for, this piece, which it is? Is it asking you for this piece, which it's not? Or maybe it might ask you for the entire length. You have to pay attention to what it's asking for. But it's asking you for VM. Now, again, VM and MW are going to be equal, so it really doesn't matter whether you plug it in here or here. You'll get the same answer. But technically, VM is 4x minus 1. So we're going to take the x out. 4 times 4 is 16, minus 1 is 15. So VM is 15. Again, if I would have plugged in the 4 here, 4 times 3 is 12, plus 3 is 15. And if it would have asked me for VW, I would have just doubled it and gotten 30. All right, identify the segment bisector of PQ, then find MQ. Well, the bisector is right here. So the bisector is line L. That's the bisector. And now I'm just going to do the same thing. The two parts are equal to each other, as marked by the hash marks here and here. So 5x minus 3 equals 11 minus 2x. All right, well, I'm going to add 2x to both sides. And actually, for space, if you want to do them both at the same time, you can. I'm going to add 3 to both sides. That's going to get rid of the number on this side and the x on this side. So 7 plus 5 is 12x equals 11 plus 3 is 14. So now when I divide by 12, x is 14 over 12, or 7 over 6. Except, hey, guess what? I'm human. I can't read my own writing here. This was a 2 up here. I kind of underlined the bottom part of the 2. So that gives me 7x equals 14. That's going to give me a much nicer answer. Sorry about that. X equals 2. But I do make mistakes. We all do. It's okay. Now, once I know 2, now remember, it's asking me to find PQ, which is this piece right here. Really doesn't matter where I plug it in, but I'm going to plug it into that one. So 11 minus 2x, which we found out was 2. So that's 11 minus 4, which is 7. So MQ is 7. And again, if I would have plugged it in here, 2 times 5 is 10. 10 minus 3 is 7. I would have gotten the same answer because they are congruent. And again, if they would have asked you for PQ, it would have been 14. All right, the midpoint formula. This basically says you're finding the middle point. The middle point is halfway, so it's really easy. If you just add the x's and divide by 2, add the y's and divide by 2, you will get the midpoint. So let's see this in action. The endpoints are R and S. So it's really simple. You're just going to do this. I just set it up ahead of time like this. It's always going to be divided by 2. And all you're going to do is add the x's together. And if it helps to label, go ahead and do that. 1 plus 4. And then my y's, negative 3 plus 2. So 4 plus 1 is 5 over 2. And 2 minus 3 is negative 1 over 2. So my midpoint is 5 halves, negative 1 half. And if you want to write this as 2 1/2, negative 1 half, that is perfectly fine. Now, this is tricky, all right? You're given the midpoint and one of the endpoints. So let's think about that formula again. It was x plus x divided by 2 equals the midpoint, x. And y plus y divided by 2 equals the midpoint, y. All right? Well, all we're going to do is plug information in. We know the midpoint, x, is 2. And we know the midpoint, y, is 1. The most common mistake here is people do 2 plus 1 and 4 plus 1. That's if they're both endpoints. This is not. This is a little bit more tricky. It's a little bit more algebraic. So x plus my x, my one endpoint x, is 1 and divide by 2. And then y plus my endpoint y, 4, divided by 2. And now I just work backwards. If I want to get rid of this 2 down here, I'm going to multiply by 2. And I'm going to do that on both sides. That cancels, and I get x plus 1 equals 4. And then when I subtract 1, I get 3. Over here, I'm going to do the same thing. Multiply by 2, multiply by 2. They cancel. I get y plus 4 equals 2. I subtract 4, y is negative 2, and my endpoint is 3, negative 2. Now, here's the cool thing about this. You can actually check your work. So I'm going to add a page here that's not in your notes. 3, negative 2, right? There's one of my x's and one of my y's. My other x and y was 1, 4. 1, 4. Divide by 2, divide by 2. So 3 plus 1 is 4, divided by 2 is 2. 4 minus 2 is 2, divided by 2, which is 1. So that's 2 comma 1. Is that what we had? It most definitely is. So when you have one of these tricky questions, you can actually take this point with the other endpoint and verify the midpoint. All right, the distance formula. Distance formula is pretty easy, but what I suggest is, here's the formula. I suggest kind of pre-writing out the formula before you do it. And I'm just going to get into it. I'm not going to read it to you. So here's the formula, okay? What I suggest you do is make the square root, and I do this. I square it. I put my minus in first because people have the biggest mistake with dealing with the subtracting a negative. We don't have any negative numbers here, but this keeps you from making that mistake. So then I'm just going to take my x's and write 2 minus 4. It doesn't matter which order you go. You just have to go the same order. So 0 minus 1. And then I'm going to do 2 minus 4, which is negative 2. And I'm going to square it. 0 minus 1 and square it. And the squaring makes sure you never have any negative numbers here. So that's going to give me square root, negative 2 squared is 4. Negative 1 squared is 1. And that's going to give me the square root of 5. And that is the distance. I just leave it like that. If I wanted to put in the calculator to get an estimate of what it would really be, you could do that. All right. So the square root of 5 is approximately 2.24. But we can leave it as radical 5. And that's it. Okay? But I did want to show you real quickly that you could do it the other way. So 2, 0, and 4, 1. Whoops. I'm having trouble writing here. Sorry. So I did 2 minus 4. Watch. I could do 4 minus 2 plus, this time, 1 minus 0. And notice I'm going to get the same thing. 2 squared plus 1 squared, which is 5. Doesn't matter which order. There you go.